Hi gang, in this video I'm going to show you how to set up and use the Stoich chart that I showed you in another video. So imagine you have this question. 250 grams of carbon dioxide are produced by the complete combustion of propane. How many grams of propane were used, how many grams of oxygen were required, and how many grams of water were produced? This sounds like a lot, but it's not. We can answer all of this by using the Stoich chart. First, we'll need the balanced chemical equation. I'll get that set up, and then I'll show you how to set up the chart. Okay, so here we are in my notebook, and you can see I've got the equation set up here. Now let's go ahead and I'm going to show you how I make the chart. So when you make the chart, the Stoich chart, there's always one column for every chemical. Okay, and then we're always going to have 5 rows. So grams for the mass, grams per mole for the molar mass, moles for the amount, the molar ratios, and of course the moles of reaction. So that one's worth talking about a little bit. Let me first bring down my molar ratios here. 1, 5, 3, 4. Okay, so what is the moles of reaction? Well, if you think of a chemical formula as a recipe, well, you know how you might have a whole bunch of people and you want to cook a lot of stuff, so you double the recipe? Or you don't have a lot of folks and so you cut the recipe in half? This moles of reaction thing, that's telling you how much to multiply your basic recipe by. And so 1 mole of reaction would just have, if I had 1 mole of reaction, I would have 1 mole of propane, 5 moles of oxygen, and I would produce 3 moles of CO2 and 4 moles of H2O. But that's not what we have in this problem. What we have in this problem is we were told that we have 250 grams of carbon dioxide. That, I can tell you right now, is not going to work out to be 3 moles. So this is not just a nice 1 to 5 to 3 to 4, it's going to be some other numbers. It'll still be the same ratio, just not those exact numbers. So let's find out what that ratio is, or what those numbers are. So what else do I know here? We know, or we should be able to find, the molar masses. So I know these: 44 for propane, 32 for oxygen, 44 just coincidentally for carbon dioxide, and then 18 for water. Okay, so remember the way the Stoich chart works is it's divide going down and multiply going up. Okay, so we're going to take the 250, remember that's 250 grams of carbon dioxide, and we're going to divide that by its molar mass. And that winds up being 5.682. Now, I want to take a moment and show you that this thing that I just did here, where we started here, okay, and I came down to here, that is the exact same as if I were to do it out this way, which might be a little more familiar to some of you. If you did 250 grams of CO2, and then you divided it by 44 grams per mole, the molar mass of CO2, and got 5.682 moles of CO2. And of course I'm using M divided by M equals N, that equation. So why do I like the chart more than doing it out this way? Well, they're both perfectly fine, and if you like doing it out this way, go ahead and do it out this way. But the thing that I think makes the chart a lot better is really this moles of reaction row down here. Now we're just doing real simple or ideal stoichiometry. You're going to get into problems likely that are non-ideal, or you're going to get into problems later on with thermodynamics or thermochemistry. Okay, and when you get into thermo, that's another place that this really shines out and becomes really important. And then last but not least, I just find this nice and easy to read through everything really quickly, especially in a problem like this where we're actually asked for 3 different answers. Remember, the question was, how many grams of propane were used, and how many grams of oxygen were used, and how many grams of water were produced. So we've got to find those 3 things, and this will let me do it all at once. So let's just keep going. So 5.682 divided by 3 gives me 1.8939 moles of reaction. And since this is an ideal stoichiometric reaction, that is the same across the board. Okay? So if we wanted now to find the the grams of propane, we're going to find the moles of propane. So that'll just be 1.8939. Then you take the moles times the molar mass, and you wind up with 83.3 grams. And you just repeat this process. 1.8939 times the 5 gives me 9.4, let's call that 697. And then that number times 32, 303 grams of oxygen. And then lastly, let's go up the water column. And so we have here 7.5758 moles, and then that will give me 136.4 grams of water. Now, last thing I'm going to point out here is that when I always told my kids, this is not your answer. This is your work. You still have to state the answer to the question. So in this case, I would state there were 83.3 grams of propane and 303.0 grams of O2 used. There were 136.4 grams of H2O produced. So that's how you set up and use the Stoich chart. Thanks for watching.